Hello students, today I will show you how to draw CPM network diagram for this list of activities as shown in this activity table. Firstly, you need to download the CPM2 template from Blackboard to follow along. First activity is A, and the activity A and activity B starts at the same time. Both have no predecessors. Double click on A to duplicate. Then next node is next activity is C. Activity C can only start after activity B completes. We shall label this activity B and create another node. And one more node here. We shall call this node number 2, maybe we call this 2. And this we shall call maybe 4. And now activity C only starts after B completes. So we duplicate this and we call it activity C. We duplicate this and call it node number 3. So activity C is done. Activity D starts after A and C completes. After A and C completes. So D. So we duplicate D. D can only start, we call it D. It can only start after A and C completes. So we put a D here. So in order to satisfy this condition, where you need A and C to complete, we draw a dummy activity like this. So P is a dummy activity, and it just shows that both C and A must be completed before activity D can start. So this is satisfied here. Next one is activity E. Activity E can only start after activity C. So we duplicate this and call it activity E. Next, activity F only starts after activity C is complete. So we duplicate this and we call this activity F. Next is activity G. Activity G only can start after activities D, E, and F is complete. So we create one more node, call this node number 5. And then, or maybe we call this node number 6. Then we create it again, double click on this to duplicate, bring it down here, call this node number 5. So activity G, we just duplicate this, call it activity G. And then to make sure that G can only start after D, E and F is complete, we draw a dummy activity linking these two. So double click on this, and this shall be our dummy activity, and we call it activity Q. So this condition is also satisfied. Now just to check, activity A and activity B both starts at the same time. They have no immediate predecessor. That's why they can start at the same time in parallel. So this is satisfied, A and B. Activity C can only start after B is complete. Activity C starts after activity B is complete. So this is satisfied. Activity D can only start after activity A and C is complete. Activity D can only start after A and C is complete. Activity E can only start after activity C is complete. Activity C is complete, activity E starts. Activity F can only start after activity C is complete. Activity F here starts after activity C is complete. Activity G can only start after activity D, E and F is complete. Activity G is here, and it only starts after activity D, activity E, and activity F is complete. So the CPM diagram is now almost complete. Next, we want to create calculate the ECT. The ECT is the earliest completion time. Before that, we need to fill in the duration for each of the activity. Activity A is duration 2 days, so we double click this and put it here, 2 days. Activity B is 3 days, double click, set it to 3. Activity C is 2 days, double click, 2. Activity D is 1 day, double click, set this to 1. Activity E is 3 days, double click, set it to 3. Activity F is 2 days, double click, 2 days. Activity G is 2 days, double click, activity G 2 days. Alright, just to double check. Activity A is 2 days, so this is correct. Activity B is 3 days, so B is correct, 3 days. Activity C is 2 days, again is correct, C 2 days. Activity D is 1 day, D is 1 day, correct. Activity E is 3 days, E 3 days, correct. Activity F is 2 days, F 2 days, correct. Activity G is 2 days, G 2 days, also correct. Next, we want to calculate the ECT. So ECT is take the previous ECT plus the duration to get the new ECT for this node. 0 plus 2 is 2. So we have two numbers here, 2. So 0 plus 2 is 2. Sorry, I started keying the wrong one. It should be this one, 2. Yeah, 0 plus 2 is 2. Then from here, here to here, ECT for this node is 0 plus 3 is 3. So we set it to 3 ECT. And then for this node, this ECT is 3 plus 2 is 5. So we set it to 5 for this node. And then for this node now, you find that instead of these 2 here, another possibility of this ECT could be 5 plus 0 equals 5. So this one can be 2 or can be 5. In this case, we should take 5 because when activity A finish, it still needs to wait for activity P to complete before we can proceed. Therefore, this should be 5. Always take the maximum. Here is 2. If you go by this way is 2. If you go by this way is 5. So between 2 and 5, choose a maximum 5. Next, we calculate this. ECT for activity 5, node 5 is 5 plus 2 is 7. Now coming to this one, there are 3 possible values for this ECT. 5 plus 1 is 6. It can be 6. 5 plus 3 is 8. It can be 8, or 5, or 7 plus 0 is 7. So it can be 6, it can be 8, or it can be 7. So we should take which one? 6, 7, or 8? We should take 8. The reason is because even though we finish early here, 6 days, we still need to wait for activity E to complete. We must always wait for the longest activity duration. Again, we also cannot take 7 because even though activity Q finish after 7 days, it still needs for activity E to complete before we can move on. So among the 3 values, 5 plus 1, 6, 5 plus 3, 8, 7 plus 0, 7, we should choose 8. 5 plus 3, 8. Choose the maximum. And finally, we create one more node here, completion node, and we shall call it node 7. Node 7. So for this one, ECT is 8 plus 2 equals 10. So this project will take 10 days to complete. 10. Alright, just to double check. To calculate this value here, we take 0 plus 2 equals 5. But over here is 5 plus 0. So we can't calculate this first until we know the value of this node. So to calculate this value node, we calculate this first. 0 plus 3 equals 3. So this is 3. So now we have 5 here, which we are not sure, but we have 3 here. So we take 3 plus 2 equals 5. So we have this node here, 5. So if you want to calculate this, you take 5 plus 0 equals 5, or you can take 0 plus 2 equals 2. So there are 2 possible values here, 2 or 5. We choose 5. We choose 5 because even though A completes in 2 days, it still has to wait for P before we can move on. So choose a maximum 5. To calculate 7, we take 5 plus 2 equals 7. And then at this node here, we have 3 possible values. Either we take 5 plus 1 equals 6, or 5 plus 3 equals 8, or 7 plus 0 equals 7. So we can choose 3 values, 6, 7, or 8. We should choose the maximum. We choose 8. Because even though D and Q finish early, still they have to wait for activity E, which takes 8 days. So only when E completes can we proceed to the next activity. So the duration, earliest completion time for this node is 8 days. And finally, to calculate this earliest completion time, we take 8 plus 2 equals 10. So when we are calculating from left to right, we call it the forward pass. We always take the maximum of the 2 possible values if there are more than 1 values for the duration. Now, in going backwards, we need to calculate the LCT, latest completion time. So in this case, the last node, we always set the same value as the ECT because we don't want to complete later than the ECT. So we fix it at 10 so that we can complete as soon as possible. Now to complete the previous node's LCT, we take 10 minus 2, we get 8. So the LCT is 8. And then to complete this LCT, we take 8 minus 1, that gives you 7. And then to calculate this one, 7 minus 2, but we're not sure yet, we have to wait for this, so let's calculate this one first. LCT for this is 8 minus 0. Remember, dummy variable has 0 duration, so 8 minus 0 is 8. And then for this one, there are two possible values. Either 8 minus 3 is 5 or 8 minus 2 is 6. So either 5 or 6. Which one shall we take? We should take 5. We should take 5, because if we take 6, then 6 plus 3 is already 9. This is wrong. This one latest completion time is 8, not 9, so we cannot put 6. Although 8 minus 2 is 6, we cannot put 6 here. We have to take the smaller value, which is 8 minus 3, 5. So when we are calculating LCT, we are doing the backward pass. That means going from the back to the front, and where there are more than one possible duration, we should take the smaller, because if we take the bigger duration, then it will fail to satisfy the requirement of one of the nodes. For in this case, this node takes 8 days. We cannot take 6 as this value. Although 8 minus 2 is 6, we cannot put 6. Because if we put 6 here, 6 plus 3 is 9, which is wrong. So we must take 8 minus 3 and 5. So we must take 5 here as the latest completion time. So going backward pass, we must always take the smaller value. And then now from here to here, we have 5 minus 2. This gives you 3. So insert 3. Now we have two values, 7 minus 2, 5, 3 minus 2, 3 minus 3 is 0. So 7 minus 2, 5. Can we put 5 here? Can't. We cannot put 5 here, because if you put 5 here, then 5 plus 3 is 8. But this one is only 3, latest completion time. So you must put 0. 3 minus 3 is 0. Remember, there are two possible values for this. 7 minus 2, 5, or 3 minus 3, 0. Take the smallest one, 0. Because if we take 5, then 5 plus 2 is 7 is correct, but here it fails. 5 plus 3 is 8, but this is 3, so take 0. So we have completed now. Our LCT is completed. Next, we want to calculate the slack time for each of these activity. Now, even though slack time means how many days can we extend a particular activity without delaying the whole project. So in this case, we need to calculate this slack time this way: 10 minus 2 minus 8. So 10 minus 2 is 8. 8 minus 8 is 0. So there is no slack time here. So slack time here is 0. We can denote it this way. We can say maybe a different color, orange. Slack time is slack time equals to 0. So the slack time is 10 minus 2 minus ECT. So 10 minus 2 is 8, 8 minus 8 is 0, so no slack time. That means you cannot delay activity G at all, because you delay, it will cause the whole project to delay. Now what's the slack time for this? 8 minus 1 minus 5. 8 minus 1 is 7, 7 minus 5 is 2, so the slack time here is 2. What's the slack time here? 7 minus 2 is 5, so the slack time here is 5. 7 minus 2 is 5, 5 minus 0 is 5, so slack time here is 5. Now what's the slack time for here? We take 8 minus 0 minus 7. Slack time of this is 8. 8 minus 0 is 8. This 8 here minus 0 is 8. 8 minus 7 is 1. So slack time here is 1. Okay. Now let's calculate the slack time for this. Slack time for this is 8 minus 2 minus 5. 8 minus 2 is 6. 6 minus 5 is 1. Slack time here is 1. Okay, what's the slack time for E? 8 minus 3 minus 5. 8 minus 3 is 5. 5 minus 5 is 0. So the slack time here is 0. What about the slack time for C? 5 minus 2 minus 3. 5 minus 2 is 3. 3 minus 3 is 0. So slack time here is also 0. And then the slack time for B is 3 minus 3 is 0. 0 minus 0 is 0. So slack time for this is also 0. So you can see here the slack time is for B, C, E, and G. So this is the critical path. The critical path is, I will show in red. I set foreground to red, so it becomes red color. This is the critical path. Okay, the critical path is 1, 2, 1, 2, 3, 6, 7. And the critical activity is this. Critical activity is, set it to red. Activity B, activity C, activity E, and activity G. Why are these a critical activity? Because you cannot delay any longer than any amount of time. The reason is because there is no slack time. Even if you delay this by 1 day, you will delay the whole project by 1 day, and you will end on the 8th day. Same with this, you cannot delay at all. So the path where the slack time is 0, it is called the critical path. So critical path is critical path is 1 to 2 to 3 to 6 to 7. This is a critical path. Not 1, not 2, not 3, not 6, not 7. And critical activity, I will call it critical activity, and probably I put green color. Critical activity is activity B, C, E, and activity G. B, C, E, and G. That is critical activity. So I think we have completed everything. If you have any questions, you can comment or ask your questions in Blackboard or in class. Thank you for watching. See you.